Right, so I draw about the probability part, right? Um, so we know what probability sample space diagram, probability like 0 and 1, probability of A plus the probability of not A is 1, right? All these here is single events. If we go to two events, right? Same thing for maths, right? This is the problem. This is A, this is B. We know that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B, right? I know you all won't get trouble with this, but that's right. Let's still, what's the probability of A and B? Probability of A plus the probability of B minus the probability of A union B, right? Let's remember those little things, right? What is A only? A only is where? On Venn diagram. A only is right here, right? Right? I saw a notation, I never saw it before. Somewhere I was watching a video. And I saw A minus B. You ever saw that before? No. A minus B is simply this. A take away B. Right? So it's what we call A only. Right? I never saw it before. I don't know where they get it from, but if ever you see it. Right? A only is just A minus B. So you have A and you minus in B. And B minus A is B and you minus in A. So it's what we call A only. So how you would find A only? How you would find A only? It will be the probability of A minus the intersect, right? The probability of A intersect B. Okay? So just something for you to remember. If they ask us the probability of A union B complement, what would that be? This is A union, complement is outside here, right? That's okay. And of course, any set notation that asks, make sure you get shaded and fine. All right. Right. These are two events. Remember, what do we call this? If the probability of A intersect B is equal to 0, what do we call that? Right? We call this mutually exclusive. And then we have the conditional events. Right? So for example, if I said what's the probability of A, given that B has happened, means this happened already, is the probability of A and B all over the probability B. Right? And you also have the other way around, probability of B given A is equal to the probability of A and B, same thing, all over the probability of A. Right? So there's a relationship that we sometimes use, probability of A given B, this by this, is equal to what? This by this is equal to this by this. Right? That's like trying to make this the subject of the formula and then equating it. Okay? So there's a nice relationship to know. And there's a special case if the probability of A given B doesn't depend on B and it's just A. This is what? Independent. Right? And we can also write independent like this. Probability of A and B is the probability of A by the probability of B. Right? So some small things to remember. Now, when you're doing the tree diagrams are used for what? What are tree diagrams are used for? The tree diagrams are used to show conditional probability. So if you find the probability of A, this is what? Probability of what? Probability of not A, right? And here, this is dependent on this happening. So this is the probability of B given that A happened. This one here is the probability of B not happening given that A happened. Okay? From every node, remember it sums to 1, right? From this node 2, sums to 1. right? If you have 3 events, same thing. All right. Every node, it must sum to 1. So these are the things that you need to remember about probability. Right? What are the two types of variables that we're going to work with now? Right? We have discrete variables and we have continuous. Right? The way we generally represent discrete variables is using a table, right? So here will be x, and here's the probability of x equals x. Probability of x given that this happened. Let's say I give you a small example like this. How do I write this probability here? This is the probability of x when it's 0, right? And then when we sum all the probabilities, we know it equal to 1. So if I sum here, here, and here, it's equal to 1. Regardless of what it is, right? You know, there's this popular question where they probably give you a die, right? And but the probability for each is not even, right? When you're working this out, make sure it sums to 1. Okay? It don't always have to be even if you have biased die, right? If it's a fair die, but you know they equal. Okay? So remember this, make sure you can find expectation. Expectation is the sum of right? It's the probability of by x. Right? So this by this, this by this, this by this, sum it up. Okay? And for x squared, same thing, you just square the x thing. What is the variance of x? Variance of x is what? E of
X squared.
Right, minus E of x all squared. Right, that's how you find variance. Also remember this. Let's say I gave you E of 2x plus 1. How am I going to find that? That will be 2 E of x plus 1. Okay? If I gave you variance of the same thing, it will be 2 squared, the value here squared, by the variance of x. Okay? The one part will be 0. Okay? So make sure you remember how to work that out, right? Continuous. Right? Most popular continuous is the normal distribution, right? Oh, what's an example of the discrete? What's an example of a discrete distribution? The binomial, right? How do we write binomial? Well, what are the two parameters that define a binomial? Number in the sample and the probability. Right? And we know Q is equal to 1 minus P. Right? For a binomial, how do we find the probability of any term in a binomial? NC, we don't give it this, right? No. NC, what you all got for the formula sheet? You all got a new one? And pure.
Yeah.
I know, but you all got a new one. You also did on it. 25 or that's good. Anything after 22, 23 is good. So that's good.
Yeah, I think median for that.
Okay, good. Right? So that's good. At least I get any new one. That's it.
I didn't get the department.
But now every school is the same thing, huh? Wow. Yeah, some schools. That's fine. Some schools don't have that and they get in a whole over. Right? Remember we use the formula someday for some of the things, right? Go on to the next one. Right, yeah, NCR
By P to the R.
by P to the R by Q to the and minus R, right? That's the way we find binomial. But binomial has a slight problem. What it is? When? Remember? We have a condition when we could use this and when we can't use it. When n is large, right? And large is what? Right? When n is more than 30, we have to approximate it to, right? So we take a binomial and we approximate it to normal by using by using continued correction. Okay? And then we do that. Remember that expectation, what you mean is what? E of x for binomials NP and variances. Variances NPQ. So to go from here to here, remember, we're going to have to get mean and sigma squared. Okay? So you gotta be able to go from one to the next. All right? Then we have the normal distribution, which is here, and we have to be able to read things off the normal distribution, right? And when you're right, can't take a picture if you need it, but you have it in your summary. No, you have this summary crash course, right? Take a picture if you want that one. I recorded this, so when is next exam? Tuesday. Yeah, real time, right?
That's not gonna be that's too deep.
And that's it between now and Tuesday, that's nothing.
Yeah.
Anybody have exam like any weird subject? No? Who? What's subject? Oh. That real question.
Especially that we're not so.
And you apply in ready to mess up, has an extra subject didn't mess up anything. Right? They will apply the. They had theirs, no, he asked it was free, so he didn't do apply to it, he can. Apply was one, yeah, was not good as. But it was there. Right? So we want to focus on the normal distribution, right? Anything else anything else in the script? Right? You just remember what is continuity correction, right? Continuity correction is whenever you have to go from a discrete distribution to something normal. Okay, that's the only time you use it. From a discrete to a continuous distribution. Let me just give you a couple examples. If you have x is more than 9 and you apply continuity correction here, what would it be? Right? So first thing you have to do is think of the first new discrete value here. What's the first discrete value here after 9? 10, right? That's okay? 9 not included. 9 is not included, so therefore it will be x is more than 9.5. Right? After you apply continuity correction. Right? Because 9 is not included. But if it had 9, if I included 9, then your first value will be 9 and so on, right? So when you apply continuity correction, this one here will be greater than 8.5. That's okay? Including the equal sign and not including don't really change much, right? Remember integrals and it don't really change much from something. Okay? What about if you had this, x is equal to 9? What would continuity correction for that be? Huh? 8.5 to 9.5, right? It will be the probability of 8.5 to 9.5. That's okay? Because the only value is 9. So you want all the values that can give you 9. 8.5 all the way up to 9.499. Right? That's okay? Because it's equal to, right? Right, make a note if you need it. And let's take a look at the normal distribution. Then we can try some on the 2. Chi-squared is 1 to 2.
No.
And apply unit 2 with the 1. The 1 is chi-squared. Three dollars. Just plug in the number. Yeah, that is the other harder. I know, so I think I'll make a. For creating.
I still thought that, yeah, I just feel like we, put like this.
Oh, yeah, I said, 2 years.
Love for feel this.
I'm back in one.
Yeah.
I can't be problem.
So my teacher like me, I really just let me somebody tell that he has speak up, good job, so.
I don't know, they teach the something about the pastor.
So that man.
All right,
I think so, what I was struggling with.
let's take a look at normal, right?
Yeah, it's the same month before. Yeah,
No one said, I want to fully go down.
Every time I go back to something.
All right. So let's talk about continuous variables. We know that, yes, I want to focus on the normal, but, remember for continuous variables, normally on your syllabus, you only get straight lines, right? You also get curves or you could integrate, so don't panic, those who can't integrate, too bad for them, right? All right, here's A and B. To give you a function f of x, and I said, find the probability. Find the probability between A and B. All we have to do is integrate between B and E, integrate the function. Right? What's the integral? What's the integral of this? The integral should be 1. Right? But this entire thing here is 1. That's okay? Right? So if at any point they ask you to find the probability, let's say between A and C, all you have to do is find the area here. Right? If they say between C and B, just find the area here. Right? 99% of the time it'll be a shape that you can just use a trapezium or a triangle and work down. Okay? But that was how they could integrate, so they could integrate. Right? So that's for continuous. The main variable, the main distribution that we're going to look at is the normal distribution. 2 parameters are mean and variance. Right? Those are your 2 main parameters. We know what the normal looks like. That's the normal distribution. This is the mean, and your variance is how far away you are from the mean. The one that we focus on is the standard normal. That's the one you'll have in your table. So for this, the mean is 0 and the variance is 1. That's okay? So we always have to standardize. How do we go from here to here? How do we standardize? To standardize, we take the value and we minus the mean and divide it by the standard deviation. That allows us to take any normal distribution and to bring it in, right? And vice versa if we have to, right? Remember that all our tables are designed to give us less than value. So if I said the probability of X is less than or equal to A, I can read that off from here. All I have to do is to find phi of A. Phi of A simply means go to its table and just read the value. But if I said less than, sorry, if I said more than A, that's here. So to get that, it will be 1 minus phi of A. Okay, so you have to look out for that, right? More importantly is sometimes you would get things like this. Phi of Z is less than negative A, right? Negative A, please remember that this distribution is symmetrical. So if you find an area here, it will be the same area on this side, right? It's symmetrical, right? So the probability of X is less than minus A. Because here is positive, it means that negative will be right here, right? Less than A will be right here. That's okay? Less than A will be there, right? You're not going to get that. You're not going to get a negative value in the table, but we know that this, because it's symmetrical, is equivalent to this. So this value is simply the probability of Z is more than E, right? These two are the same things, right? Regardless of the shape we give you, right? Regardless of what they're asking you for, you should be able, right? You should be able, if they ask the area here now, how you'll get up. What will this be? Right? A few ways you can work it out. Probability between minus A. A few ways you can work it out. The long way is to find less than A. Right? The long way is to work out this whole thing, which is phi of A. And then minus of this here. From minus of this piece here, which is this, which is 1 minus phi of A. So the formula becomes 2 phi of A minus 1. Right? If you're good at memorizing formulas, you can have the formulas in the summary, right? Right? But I like it to be able to work them out. Right? So these are the things you need to know. Remember, if you get question where the binomial gets too big, you use the normal. Right? Just one more thing I want to ask you. If they gave you the probability of Z is more than A, it's a value bigger than something like that. How you finding? How you know if A is positive or negative? Right? That's where this comes in. Right? And you know, so I gave you a summarized version, but it's good to know when you see it, just to work it back over. Real short. Remember, this thing's symmetrical, right? So the probability here is 0.5, and here is 0.5 as well. So if the probability is 0.7, where would A lie? Could A lie on this side if it's more than? Could A lie on this side? No. There's no value for A that will give us something so big. So it means that A really is here. That's okay? A is here. And A is negative. That's okay? So if it's more than and it's more than 0.5, A negative. If it's more than and it's less than 0.5, A positive. Okay? And vice versa if it's less than. Okay? So sometimes they could ask you to go from the probability backwards. All right? So in case they ask to go for the probability and then find what A is, do a little sketch and then try to work it out. Okay? All right, let's go into some questions now. Right, I don't really have, I don't know if I can't find what the years. I think we did all the recent years, right? That's 5 or 6 years. Anybody have like six, we call a whole textbook, like a whole passbook booklet with the syllabus, something in it? Anybody have that? Class guide? I had one, I guess, right now in the type, but I'm gonna see today, fellow. Right, the lesson 2019 now, 3 and 4. 2019 number 3 and 4. I have it. Check any group ones.
And.
When you have 2019, I can just share it back in the group. You have it, just share it back in the group now, 2019. Right, try both 3 and 4 in 2019, right? Okay, guys? Just check that out. Just. Right, we just do like 2 module. Yeah, let me just focus on module 3, we get time to come, right? 3 and 4, yeah, do that fast. Well. That's how to correct that's not right. Almost done? Done. Okay, yes. Right? Right, forget that, oh, forget it. Because I just adding something when it's sampling, that sample I sent you out didn't have it. You can read a sampling later, we are adding like a super technique. Like we have 100 people, we have to add in a structure technique, like for example, say form one had uh 50 people, form two, so and so, and then we select by proportion, right, to getting 100. And then we have to add some problem calculation into the analysis. Like conditional probability. I think we are adding some problem. That's okay. Put the pattern analysis. Okay. All right, let's go. All right, let's go now. Yeah, what 2 minutes of me, I wait for that challenge. to go to school. One time. So when we correct, I'll send one time, right? But sounded like today on one, yeah, right? I forget. It's what you right. Huh? Yeah. Yeah, but I want to send it. I want to send it before the exam. Okay? I will send it up this week. Just two little things that you have to add. All right, the first one there, the students in a particular class at the school all study French, so all study French or Spanish, so go to them. They give it, so there's nothing outside those steps, right? So probability F, probability S, calculate the probability that both are selected. That's not. Right? What's the probability F union S? What that's supposed to be? F union S is what? One, right? That everybody's doing it, right? Everybody doing it. So the probability of F union S is 1. So the probability of F and S will be the probability of F plus the probability of F minus the probability of F union S. So that's 0.65 plus 0.72 minus 1. How much is that? 0.37. Then they want the probability of French, given that they study Spanish. So that's French and Spanish all over the probability of Spanish. Okay, so that's 0.37 all over Spanish, which is 0.72. What's that? 0.51. Right, that's part 1 and 2. That's it. Part B now, by something different. Right? Part B, they gave you all these values, so these are much easier. And they gave you part represents M does occur, right? Calculate the probability of M. We know that will simply be 1 minus 3/4, which is 1/4. Right? Then they want the probability of M and N. What they give us? They give us union. They give us this here. So we can use the probability of N given M by the probability of M. Right? N given M is 1/3. M is 1/4, so that's 1/12. That's okay. What they ask for after probability of N. They want the probability of N now. We have plenty different options. What the option we're going to use? We have union now. So we're going to use to find this, we're going to use the probability of M union N is equal to the probability of N plus the probability of M minus the probability of N in the second. Right? Probability N is what we're trying to find. N union N is 2/3. This is the probability of N. The probability of M, we found it already, and we found the intersect to be 1/12. Right? So the probability of N will be 2/3 plus 1/12 minus 1/4. What's that? 8, 9 minus 3, 6. Yeah, 1/2. Nice. Right? Easy stuff, right? And state whether they are independent. Are they mutually exclusive? No, can't be mutually exclusive because they have an intersect. Check it out and see. Probability of M is a half, N is a half. By 1/8, that's 1/8. I mean by 1/4, that's 1/8. So are they independent? No. They're not independent and they're not mutually exclusive. Okay, so you just use the just multiply them out and see, right? So they are neither. But see now, what distribution is that? Binomial, right? So a game consists of tossing it 3 times. A player estimates that the probability that he will hit the bullseye on any throw is 1, 2. The number of X is the number of times hit the bullseye and it's thrown 3 times, so we know N. So always give them a distribution. X follows a binomial with N 3 and the P 1/3. Pay attention to the small little thing, right? 1/3 is to hit the bullseye. Make sure the question, make sure when you define X, X has to be hitting the bullseye, right? You get all tricky and put not hit, right? So now we want the probability of X is equal to 2. So that's NCR, R is 2, by 1/3 to the 2 by 2/3 to the 1. How much you got there? 219. Yeah, 219, right? Now they want us to construct a table. They want us to construct a table. So the options are you're not hitting, you hit once, you hit twice, you hit 3 times. We just work out for 2, that's 2 nines. When you all work out 0, what you got? Huh?
8 on 27.
8 on 27. Once is what? 4 9. And then you hit minus and get the last one, right? How much? 1? 1 on 1. Right, so you work out the first 3 and you minus to get the last one, right? Are you okay with that? Yeah, are you okay with that? And they want expectation now. So we already have the table. So to find E of X, what we have to do is 0 plus 4 nines plus 2 by 2 nines is 4 nines plus 3 on 27. Right? 4 was that 1? I think I 1. Yeah. Let's go again. Right, if you have time or you go back over the ascending length for the crash course, go over module 3 again, right? But that will be more in depth with module 3. Go it over and go over the same question. You have real time, right? That 3 days. 4 days. Didn't want not even Tuesday. Or the right here, right? So you just come and get time table. Morning, have a start 9. One of them. Right, right. This one real simple. This is 3 E of Y plus 2. So that's 3 by 3.8 plus 2. How much that was? 15.4. And then you have next one, that'll be 9 by the variance of Y. So that's 9 by 2.1. 19.4. Right? Okay. Also, I saw this came up earlier here, where they give you 19.44 and ask you to find variance of Y. So just look backwards. Okay? Just make sure you remember these are the rules, right? All right, nice. Let's do the next one quickly. First part is just to list the distribution. 3 reasons. They'll remember the 3 reasons, right? For binomial. And see the parameters. Well, what are the parameters here? N was how much? N is 12 and P is, right? So remember you have the word cards, right? Picture cards are what? King, Jack, Queen, you have 3 by, so that's 3 and 4 suits, right? So that's 12 1, 52. So you have normal cards, right? You have picture cards, king, queen, jack, and well, non-pictured. You have 3 suits. Right? Or some totally different now. Part B, a driving instructor believes that 73% will pass their driving test on the first attempt. They have 15 students, right? So they want even if you know what expectation, please write down the distribution, right? X follows a binomial, n is 15, and the probability is 0.73. Determine the number of students expected to pass the driving test. That's expectation. Expectation is n by p. So that's 15 by 0.73, and that's 10 point. So you put approximately 11 in. Approximately, right? 11. Always put the exact value to it, right? They expect approximately 11. Find the probability of exactly 12. So you want the probability of exactly 12. So that'll be 15 C12 by 0.73 by 12 by 0.27 by 3. To the power 3, sorry. How much is that? 0.205. Are you okay with that? Yeah, you are okay with that? Ali, are you okay with that? Right, it changed a little bit now. You get more normal distribution than binomial. Like this question was more binomial to paper. It already happened so much, right? Next, they gave you a normal distribution. X follows a normal. Right, mean 12, variance 4. My advice here is do write variance, write standard deviation squared, right? So they want now the probability of X is more than C is equal to 0.9583. Okay with that? Right, as I told you before, it's more than, so therefore C is going to be negative, right? Negative C is the same as this here. It's more than, right? Sorry. Front to front end. Oh, that's right, I'll front end. Hold on. We spent a long time. Right, this is minus C. That is equivalent. That's equivalent to this, right? Right, that's equivalent to that. So the first thing we do is standardize probability of C. Right, if you go less than, you just have to remember to put the minus sign in front, right? C minus C minus mu all over sigma, right? Is equal to 0.9583. C minus 12 all over 2 is equal to pi inverse of 0.9583. Right, we ignore the sign for now. As I said, we put back the sign in the end, right? So what shall I got to find first? 1.7. 1.731. You multiply that by 2 and you add 12 then. What is that? Let's see. 15.46. Right? This implies that C is equal to negative 15.46. That's okay? Right, as I said, if you want, you could put this C minus, right? Would make a difference all the way up till the end. Right, we know it's minus because of, right, because the more than and the value is greater than 0.5. All right? Yeah? Sarah? And last part D. Part D, squash harvest from a certain farm have masses which can be modeled by a normal distribution. 5, 7, 8, and a standard deviation 35. Calculate the probability that is squash chosen at random from the previous day's harvest will have a mass of more than 600. So the first thing we do is standardize. X is more than 600 or all over 578 all over 35. Right? That'll be probability of C is more than what? 0.62? 629. Right? Should have be little diagram more than is here. Right? So that'll be 1 minus 5 of 0.69. What's that? 0.2643. So look at that. It on the table, right? 1 minus, right? Right, remember when you have a table value and the table value is given the same thing, choose this smallest one, right? So if you have three different but all given the same, choose the one with the lowest. Choose the first one. The vendor randomly selected 50 squashes for sale. So to find the number is simply the probability of X is more than 600 multiplied by 50. And you also get that one, 0.2643 by 50. How much is that? 13.215, which is approximately 30, right? Doubles?
So if it.
Okay, I'll go with my again, right? Go with the 47. Okay, you got that different. Okay. Right, but you get approximately 30 in next one, right?
Say around 51.
It does?
50.
Same thing, right? Yeah, exact around 50.
It's go.
Yeah, and this one you'll round down. You want to round down.
And I feel like some question, there is the answer. Yeah, that's it.
But always write the exact value. Always write the exact value, right? Right, because remember it's probability, so you can get 30, you can get 14. right? And one last one here. Squash that are weighing less than 525 are sold at cheaper price. Right? What percentage of the squash harvested would have to be sold at cheaper price? So you're doing the same thing again. Probability of Z is less than 525 minus whatever it is, and then you work it out a negative value, right? Right? So remember it's a negative value, it should be less. What was it? Z less than what? Minus 1.5? 1.51. Right? So that'll be here minus 1.51. That's the same as more than 1.51, right? So that's the same as probability of Z is more than 1.51. So that'll be 1 minus 5 of 1.52. And you all got 0.0655. And then right here, and then convert to percent. That's divided by 100, 6.55%. Right? Let's jump into module 2 one time. All right, next one. What document that we will talk about?
Why you get us over there? Thank you so much.
Yeah, I'll play that. All right, let's go one time. Right, so remember module 3 is about interpreting data, right? So there are 3 things you can get. You can get point estimate, where you have to estimate a point. You can get where you have to, for example, I could ask you to find a mean, right? And you have to find the exact value. There's a point estimate. I could ask for a confidence interval where the mean lies, and then I could ask you to do a hypothesis test to see if that mean value is more than, equal to, not equal to or less than. That's okay. That's basically three things that you're doing in module 3, right? And of course, you have a chi-squared and you have your regression analysis. Okay. Right. So point estimates. For point estimates, remember, if you do have your estimates from your population, you have to estimate them, right? So if you look here, these are the symbols that we use, right? These are the symbols that we use for population values, right? The mu symbol, P, sigma squared. But if you estimate for the population, you put a little hat on top, right? Sample will be X bar, PS, and S squared. Okay, so pay attention, especially for the little problem that we have with S squared. If you take a sample and you find the variance, we call that the what? Sample variance. And then we use this formula, S squared, N on N minus 1, to get the population estimate of the variance. Okay, do not make this mistake. It's a mistake that we generally have problems with, right? And then if instead they give you a sum of X squared and they give you the mean, you can use this formula and find the estimate. Okay. Right, so just remember that, right? Remember, if you get S, forget it, right? Right, nice. So remember this distribution whenever you're doing confidence intervals or you're doing hypothesis testing. This is the distribution that you're using. It's called the sample distribution of means. Right? So if you have something that's normal, so if you have a normal distribution where x is n, a normal with mu and sigma squared. If you have a normal distribution, then the sample distributions of mean is make a little mistake there. What's the mistake there? In this line. What's it supposed to be? X bar, right? X bar means sample distribution of mean, right? So the sample distribution of mean is also normal, right? Same standard deviation, but the variance is now sigma squared on n. Okay? Right? Sigma squared on n. Right? Sometimes they have something called standard error. Standard error is just square root of this. Okay? Right. Whenever something is not normal and if it's not normal and you have a known variance, and this holds for everything, not normal, known variance, and n is large, we use this person here, central limit theorem. Right? We use central limit theorem, and now we can say here's what we can approximate it to a normal. That's okay? So you don't have to be a normal once the variance is known and the sample size is large. We use central limit theorem, right? Right? And then, well, if it's a proportion, we use sample distribution of proportion, and it's written like this. Right? Make a note of this one. This is if you have proportion, right? If it's a proportion, sample distribution of proportions, still normal, right? P, Q, and N. Okay? That's if it's a sample distribution of proportions, right? Proportion, if you see the start giving you like 5 out of 200 and those kind of things, you know, it's a proportion question. Right here, we have all the different options for confidence interval, right? So you can learn them, but here's what I want you to focus on. To work out confidence intervals, what's the main thing? You need X bar, plus and minus your critical value, right? By sigma on root n, right? How do you get a critical value again? Let's say it's for 95%, like the one they give us there. Right? Remember, these things are like field tests, right? So 95% this here. This is 90. Well, okay with that? So on either side is what? Right? 0.2, well, already wrong thing. Right? On this side is 2.5%. This side is 2.5%. So what is the value that we have to read off if it's 95%? You're reading off the value for 0.975. That's okay? So if they change it to like 94% or 90%, you still remember inside here, divide by 2 and minus 1. Right? Divide by 2 and minus 1. Right? And you read that value off. That's okay? That gives you a critical value all the time with 1. Right? That gives you a critical value all the time. And once you have a critical value, you find sigma on Newton. Okay? If you do have sigma, estimate sigma. Right? But what would happen if you do have sigma and n real small? Right? Come down here and use t distribution. Right? So if we do have, if variance unknown and sample size is less than 30, then we come here and we use t distribution. That's okay? Right? Remember, well, what do you read off to get a critical value? T by n minus 1. Okay? Based on the percentage, right? Based on the percentage. Right? So just do me a favor, just sum of this value there. T for 9 degrees of freedom, 0.05, 95%. What's that value from the table? Take it and see. Go to your table and read that value up. 95%, right? No. How much? 1.83. 1.83. Okay, let's make sure you can read the table, right? Make sure you get that same value. Get analyst. T distribution. 1.833. Okay. Right, and then if it's it, well, they can ask you these little things. By increasing these, if you want to reduce the width, you can increase the sample size, you can decrease the confidence interval, or you could reduce the size of the population variance. Right? Like if you want to make the width smaller for the confidence interval. And this is the formula for proportion, right? If they give you a proportion, this is the formula. Right? These are the three types of tests that we have to learn to do. A lower tail test, one tail, lower tail test. How you know if it's lower tail? Less than. Right? And the rejection region the same. It's a lower tail test, right? It's a lower tail test, it's a one tail test. So what you reading off? If it's at 10%, what are you reading off? 0.9, right? And it's a lower tail test. If it's a upper tail test, it will be more than 10%, right? If it's a two-tailed test, what you're going to read off? If it's 10% significant level, 0.95, right? It's a two-tailed test, so you're doing the same thing that you would have done in the confidence interval. If it's a two-tailed test, it can be less than the negative or more than the positive, or just simply more than the modulus. Okay? That's what two-tailed test. So you're looking out for those symbols, right? Not equal to more than. The hard thing is you have to read the question and decide based on what they say, right? If it's more than, less than, not equal to. And well, I just give it some different values. Say it is 5%, right? Or 1%. You learn them off, or you can just learn to work them out. Okay. What are the stages of a hypothesis? People remember that. First one is the what? Right? Well, you define the variable y by x is, right? After that, steady null, steady alternate. The alternate, you have three options. Lower, upper, two. Next, consider the distribution being used. The distribution, what are the two options that we have? The x bar and the chi-square. Okay? Right? X bar, always write that earlier, or do start to work it out and you leave out x bar. Right? X bar is a normal with mean mu and variance, sigma squared on n, right? Don't leave that out, right? Then steady type test, that will come from your alternate hypothesis, right? And decide on the rejection region, which kind of also comes from your alternate, right? And after you do that, find the test value, right? Remember the test value per C and T. What's the test value per C? Oh, yes, find the test value per C. Remember, we are compare it. X minus mu over root. Right, well, you can square root it, or you can just write the theta and right? And then what you do after that? After you have the test value, compare test value to your rejection region. If it's inside the rejection region, reject each node. If it's outside, You accept. Right? And then you have your options. You have your options when testing for unknown population, not normal, but the sample size large. Right? It's normal and you have to estimate sigma. These are the same things that we did, right? Right? That's how you get a test value. Remember, it could also be a binomial and at large t distribution, right? So same conditions from confidence intervals, same conditions that we get here. All right, so we have to look out for that, right? And then you have regression calculations, right? You have your formulas just to pull them out and find regression. Let's focus on hypothesis testing. Let's go back to 2019. This time we do it together. Right, go to number 5. Tell me how we start in this. Go to number 5. Ready? Take a little read. The results of a certain examination are known to have a normal distribution with mean mu and standard deviation 15. Determine the sample size that is needed for the n value that is needed to achieve 98% confidence interval for mu to have a total width of 8. Right? So here's where we start with. Okay, I'll give you 2 minutes. We don't know mu. We don't know mu, but we know the width. What does width mean? The upper boundary minus the lower boundary. Okay? I didn't officially give you a formula, but if your upper boundary is this, that's very critical value, right? And your lower boundary is this. Well, what is the class width? Right? How you get it class width? Class width is your upper boundary minus the lower boundary. So when you minus this and x bar will cancel, and you will get 2 of these, right? So you will get 2 by the critical value by sigma on root 10. That's okay? That's the class width. So if you know your class width, you have it here. Find the critical value. You know sigma, you can find the root 10. Correct? Try it quick, see what you get. That's a standard formula if you want to write it down, right? For class code. Right, how much you all got for the class width is 8? The class width is 8. And sigma was 1.5, no, sorry, 15. And we're trying to find root 10. What you all got for the critical value, remember, is 98%. So here will be 1 and 1. So you're reading off 0.99. But what you all got for the critical value? 2.326. Right? Don't forget that, right? Right? Cross multiply and then square. Right? Cross multiply, divide by 8 and then square. And it's how much? How much? 76. 76. All right, let's go to the next one time. 95% confidence interval between both of them. Calculate the mean. Right, so the way calculating mean now, they change the confidence interval now, huh? But we know the sample size, right? We know the sample size. So find the confidence interval. You're done? You're done? When you minus them, what you get with them? When you add them, what you get? Huh? And you get 2x bar. So 2x bar is 3177 plus 33.23. So x bar is simply
So
divided by 2, right? That's what, 64, 65? Sorry, 66. 65. 65. Here we go. Right, so that's what, 32.5? Yeah. Because I think that sample size that we got was the part 1 only. So we could use that n. The next way is to what, solve simultaneously. Huh? Yeah, I don't think we could have used that n. based on that part one. Part one was n for that condition at the time. Alright, let's go again. Right, so let's go here. Right, they gave us a random sample of 150 measurements of a variable y, produce the following results. They gave us sum of y and sum of y squared. Calculate the unbiased estimates of mean, right? It's 150 and variance. Did that pass? Double Kelly, double Tara, what's that? When? How long will it take? 5-10 minutes, just let me show you. Right, it's just meant to show you the two things to add in. We just have to add in above the regression and the correlation, we have to add in a probability. And you'll remember when we do a stratified example, I'll just give you a table, form one, and then select by proportion. That's it. Two things that missing. I told you anything else? What was the next thing? Title, I can't remember what's all of them. Right, you all have limitations. Yeah, so any limitations, like for example, the sample size small, right? Any limitation they probably have. Like when we collect the data, we don't have the kids of truthful. Right? And you can just tell them how it becomes it. Their parents involved with a bigger sample size. Right, so in about 10-15 minutes after we do all this, we'll sit down and we'll just fix the problem. Right? We just do some example minutes. What are you doing stuff? 6 o'clock? 4. You're done? Make sure you use the right formula. Eh? Look at what they give you. They give you sum of y squared and sum of y. Right? So let me just make sure you're using the right formula.
Okay.
But you'll get y bar. Right? So that would be the sum of y on n. So that's 3825 over 150. You got what? 35 25.5. Right, yes. So how are we going to get the variance now? Tell me the formula. What's the one in the what's the formula in the I think there's one in the sheet. Check the sheet there. Have any? Let's see. Yeah, that's one, but that was me a problem. Yeah, well, well, the people who formula here. But that is the final movement is around. Yeah. This is a new one, so Right, yeah, so you do have it. So what's the formula we're going to use here? Grade one. What's the formula we're going to use here? Okay, right, and then the next version I gave you in the summary, n minus one by the summation of y squared on n minus y bar squared. Both of them are the same formulas, right? The one you called us on this one. Look it out fast. Right? If you use this, is the same thing as 1 on n minus 1, sum of y squared, y bar squared on n. Right? Check it out, Omega. How about yours? How much? 24.
Here you go, please. 590, so.
598.74. What they asked for? Area, right? Everybody get that right? Stick to this formula, right? Next one. Say the appropriate distribution of sample means y bar. What's the distribution again? Y bar follows a normal distribution with mean 25.5 and variance. So 598.74 over 150. Don't forget after over 150. Right? Sigma squared on n, right? What you ask for after? Determine the approximate confidence interval for the unknown population mean. Do that pass? They want the confidence interval. right? What's your lot? Right, well, we know the formula, right? X bar plus and minus. What was the critical value now? 1.96. And your sigma is what? Root of 598.74 all over 150. Yeah, it is very good. I carry this 7. Right? And the X bar value using is what? 25.5. Fix it up quick. Let's go to this one here. I guess I'll do a hypothesis. That's right. And the regression chi square or what? Right? Come part C when you're done. Right? Go to 6C. Let's do 6C. But okay, with our last one there, right? Let's plug in your values and work it out, right? Go to 6C. Take your time, identify your null and your alter, right? Right? Let's just make sure you have it right. Right? So the masses of loaves of bread produced by a certain bakery follow a normal distribution with standard deviation 50. So they give us standard deviation, right? The mean of a randomly sampled 40 loaves is 447.5 grams. Do a 10% level of significant test to determine whether the population is right. So H naught is what? Mu is equal to what? 400 and 450, right? Mu is always for your population, right? Your population here is 450, right? What's the H1? Huh? Mu is not equal to, right? Because they want to see whether it's 450 or not, right? So they didn't specify more than or less than. Right? So mu is not equal to 450 grams. Right? If you want, you can also write it in words if you want. The mean is equal to this. The mean is not equal to this. Okay? So what type of test is this? So that two-tailed test, right? Right? So your critical values will be here and here. That's the rejection region. They want the critical values, right? So inside here is what percentage? 0.9. Work on the critical values. Right, go to your table. Work on the value. What's the value you're reading off my table again? 0 point. Right, you're reading off the value that corresponds to 0.95. Right? Read off the value that corresponds to 0.95. The critical value is what? 1.645, right? Well, you should know those values by now, right? So your critical value is 1.645. We actually critical value it, not the rejection region as yet. Right? The rejection region is where you tell them more than and less than. Okay? Turn the page, go to the next side. What would the rejection region be, Keisha? What would the rejection region be? My right. My right. MC is less than. Somebody about it. I want to make sure you're right. Correct. C is less than. Right, C is less than minus 1.645 or C is more than 1.645, or I would write modulus. Modulus of C is more than 1.645. Right, how you get test value again? Test value is what? C is equal to x bar minus mu all over sigma Newton. Book it out fast. Let's see what you get. Right, you have x bar on the part before, right? That was 4 point something. Find your x bar, and then I take the actual conclusion after. Because that would pretty test for value. How much? Minus 1.05. Okay, just get up. So when you modulus that, is it in the critical region? Haley, in the critical region? Modulus it. Modulus is 1.05. Is that more than 1.645? No. So we do not reject at the 10% level. We do not reject at the 10% level, I tell them that the mean is actually 450 grams. Next one. Again. Right, chi-square is just a move of one example, right, Olive? Just look at the page and look at one example of chi-square, right?
Yes.
Let's do our next one. I think I have 22 here. Right, because the crash course, we would have done 25, 24, 23, 22, and 21. Right, you would have done those years. 20 has none, right? Huh? 20 was just good one. This one pass. To this one here, right? Do whatever year it is. Just do it. Come on. Let's see what that's. Yeah. Go down, go. Right. Yeah. Yeah, okay, something else. Right. Right. Money is not taken. Right. What? Okay. Okay. Thank you. Like we said. So. What's coming? Five. Select one. Change from Google to start. I thought it was all. This right above the analysis. So, right to the. It's a new habit. Okay, yeah. So, I mean, we will understand, right? Right. Yeah. Right. We will. Yeah, no, and attractive. You can pick up. Don't want to. Thank you. Keep. Right. Right. Okay. Right. Then to get this, you will get. I just need this one fix, one good, one good. Oh, it's the other way. Well. But that's. Okay. That's a new thing that comes. Some research. Okay. Well, I just go. Now that and then.
We change our 100%, right? Right, it's on top of it. When that's the areas, you find it out. That's certain for 20. Right? Okay, and that's easy fast. Go to. Right, oh yeah, no, right, that's the U, center. Right, now we can set our fix it. Right, that's. And we'll take all on. And now we'll make it. It's not the. Like those small, whatever we do. Right. Because I think that not all my people. Right, that's what makes sense and that is. Not usually, you don't do this. Hopefully she's not in the exam.
Right, but there's one more group, so I'm hoping that group will finish well. Right, but remember, two others go away and think. We are going to apply the two SB before, even if you don't know what the topic is. Right? That's a longer module, it's a longer SB. Huh? Right. Yeah, so we'll do it in July, right? Yeah. When that, so. Somewhere in between, do you want every day SB? Until what time?
Well, it's sure you listen.
Right there, one morning, and I have lessons all morning. Right? You're done? Oh, take a little read in the meantime. Take a little read, and the fella's going to help us do this. Coming back, when I come back, I might do like our Macedonic group, so I'm going to third. Right? But I will be here from Friday, Tuesday. Do you have any exam at that time? What is the first exam? Right, so Michelle will start Wednesday and Thursday. I'll do. Which one is which one is Friday? Pick one, so I might start Saturday and Sunday in the night. Somebody click the yes, and then when I come back to Wednesday and Thursday, we can do it in person about it. But I will start in the morning. Right? Try to get the 10 years done, right? Or they have past papers. Yeah. I think we are 2025, right? Or they have that too. Paper one. Who have they have one? We get 7 of them. Right? Or it had copies. Oh, you have non-stop copy.
Yes.
Why can't you take pictures, right? Oh. But you have 25. The booklet didn't have 2025. It was the same booklet. It had until 2024. Okay, check and if you have it, send it. Because nobody else, I don't think I had 2025. I had it here, and then somebody had the one and take it up on one or so. I think we were getting key papers last. Okay. I'll send it out. section where because you'll have center and groups on, right? Whereby they have center and groups. Right, let's go. So a random sample from a population with mean mu and the standard deviation sigma yield the following. These are sample values. So you're going to get sample variance and sample mean, right? So what you all got for this sample mean? Right, sorry. What's your got for this sample mean? 14.7. Gemini Korean. And it unlimited, like the amount of food.
I don't know.
No?
I'm not cool by no.
So that more than the free word when ChatGPT. And Gemini just come with anything Google. But it is Gemini Google.
Because it's. Can I?
Alright, so sigma is x bar is 14.7 and s squared is 0.55. S squared, right?
Yeah.
Right, so mu hat is this and sigma hat is this. You okay with that? Right, determine the critical region for a test. They give you the null hypothesis as 14, and this is not equal to 14. What type of test is this? Huh? Yeah, two-tailed test. Huh? Yeah, t-test, right? That's all looking for, right? I'm just making sure that part 2 linked to part C. Right? So it's a t-test. Okay? It's a two-tailed but t-test. How you know it's T again? Arab, how you know it's T? And the variance is unknown. Sorry, I make a mistake here. I test twins. Right, remember this is n over n minus 1 s squared, right? 1, 2, 3, 4, 5 values. Right, they asked for sample variance. I just wrote it down because you might need it after, right? Very good. Right, I don't know exactly where it's going. Why not go? And fill up which skeleton. Right, so they want the critical region. That's it. Oh yeah, fix it fast. T-test, everybody, fix that. Huh? Okay, hindi. Right, t-test. Right, it's a two-tailed test. 5% significance level, so 0.95. How much degrees of freedom here? T-test 5, 1, 2, 3, 4, 5, right? 5 minus 1. What? How do we this go then? Right, 0.95, so that's 5% on each side. I'm sorry, 2.5 on each side, so you're reading off of 0.975. That's correct?
Yeah.
How much is that?
So.
So the rejection, they actually critical region, right? So the critical region is the modulus of T is more than what? 2.77. Everybody okay with that? Everybody okay with that, right? Oh, well, that's it. So it has more there. Do my favor now. You can just complete the rest do the no, it don't have, they didn't ask for anything else, but could you find test value, find the test value and we check, see if we're going to reject or not. Find its test value. What's the formula for the test value again? X bar minus the mu all over sigma under that. Put sigma hat there because we had to estimate it, right? And I found sigma here for you. 514 by 0.55. That's okay? Don't forget that, yeah? Remember, the 0.55 was S squared, right? Correct? Right, so sample variance S squared. Right? You got that for sample variance? S squared? You got that? Yeah, I was wondering. I suspect that 0.55 was this, your n over n minus 1. Yeah, so switch that coming up. Switch that coming up. Once you use n over n minus 1 or 1 on n minus 1, that means that you're doing it pretty variant. Yeah. So 0.55, but they wanted sample variance. So let's just say you n on n minus 1 S squared. All you have to do is just rearrange the formula and find for S squared. And you got what? 4 S squared. 0.44. That's the sample variance. That's S squared. 0.55 was sigma hat squared. Right here, find the value and put up sample variance 0.44. if you use the formula that we had with, what's the formula you use to define S squared? Well, to find zero to get 0.55. N on by what?
Yes, we are.
Right, so that value you found there is this. That's this value you found there.
That is proper also.
So to go back now and find S squared, just rearrange this formula right here. Right, rearrange this formula, because they ask for sample variance. What's all got for the test value? 2.11. So do we reject? No, right? No. We don't reject. Right, I like to use this version or the modulus version. It's easier to see the rejection, right? Some people just struggle to figure out the minus less than. Right, we have a 10-minute, oh, the parents come in, they might have to pull up and pick you up, right? Without all the parts. Right, yes, nothing in prayers, but prayers are. Yeah, all they're full of the parts, so they want to come and pick you up in front. I think I message them and tell them like when they coming up, they tell us full. Or you can pick up on that side. Right, regression, what do I have to say about regression? Remember the formulas? Right, remember your formulas for regression. As I said, you don't really have to learn the ones like other version I gave you because it's in your formula sheet. Right? So regression analysis, remember, is basically y is equal to what? What's the regression line? Y is equal to what? Yeah, just give me the line. Y is equal to what? A plus bx. B is what? B is the regression coefficients, and A is a constant, right? A is when x is 0 basically. Okay? And you have your formulas to find B and your formulas to find E. This only works for what? Y on x, right? Suppose it's x on y. You basically just rearranging the formula, right? X is equal to C plus dy. Right? You just change the independent variables. Okay? Y is considered, which one is the independent variable? Y or x? X, right? X is the independent variable and y is dependent on it. Okay? Whenever you're doing a scatter plot, you go ahead and do your little plot thing, right? But suppose you had to do a regression line on that, or best fit line. What's the point it have to pass through? Right? It have to pass through x bar, y bar. Okay? So you do your best fit line, but make sure it passes through x bar, y bar. Okay? After. And then correlation, that's the R value. Correlation, the long formula in the formula sheet. And it's between what? -1 and 1. So if your value close to 1, what type of correlation is that? Positive 1. A strong positive correlation, right? And if it's close to -1, strong negative correlation. If your value is like 0.1, what you would say? A weak positive correlation, right? If your value is like 0.75 and say, what you would say? 0.75. Yeah, you can still say strong, right?
With the dress.
Suppose I'm more than 0.7. Suppose it's like 0.64. Oh yeah, yeah, almost getting. What you would say for 0.5? And that's so weak. Below than, yeah, moderate, right? Below 0.5, you can start the same, right? Somebody SBA was like that. Because it was lower than 0.5, right? But it worked out good because the chi-squared checked it. But I was good. I was worried that the chi-squared would have said that there's a relationship. And although it was extra high, the real makeup values. The makeup values perfect. Who study hard, they're high good. right? So that means your probability should also be high, right? When you study more than a certain amount of hours, that conditional should be high, right? Alright, so that is the regression. Chi-squared, let's talk to chi-squared. Chi-squared is a goodness, is a test of what? Independent. You're checking to see if the two, you're checking to see if one is dependent on the next, right? And each node is what? Each node is a null, which is always what? No association, and your each one is an association. Chi-squared, what was the critical? What is the critical region? Chi-squared is always greater than the test value, right? Always greater than. Chi-squared has no other option. Okay? My advice is take the crash course. We did a lot in crash course over those videos, right? Especially module 3. I think I shared the link in the group, right? If you didn't get it, message me, right? I'll send it for you. One is up, right? Well, oh, sure. Yes. Who pay the crash course? Right, do me a favor, right? Send the 329 number, your receipt, right? And reminder. And worse, if you don't give it back now, I can just transfer it to the holidays, but I could do couple lessons, I will have to give it back, right? Right, well, send why pay it online.
I will pay $53.
What?
No.
No, do the office do it. Don't do all that.
Well, sir,
Huh? Yeah, but just tell them, send them so they will be out there. And she here tomorrow. And you get tomorrow, so she would do it for you, right? Don't forget that. She have to do it. I will be here tomorrow too, so. Alright, so do that. All the best now there. Hey, we didn't, anyway, we are praying now.